Okay, let's solve this trig equation. I've got a quadratic. Anytime somebody gives you a quadratic, it's probably going to factor. So think factoring. Notice here, though, that I've got a sine squared and a sine. I don't have a mixture of sines and cosines and tangents and whatnot. Everybody's sine. So you could do this game where you do let u be sine of theta. And then I could rewrite this as 2u squared, because that's u squared, plus u minus 1. So that's one way to approach this. And if you watch a bunch of videos on YouTube, you'll see people doing it that way. I think at this point, though, you should be good enough at factoring that we can just factor this the way it lives. So I want things that multiply to 2 sine squared here and here. So that's got to be a 2 sine of theta and a sine of theta. And then I need things here and here that multiply to -1. It's got to be a +1 and a -1. We just got to figure out which goes there. Is it -1 plus 1, or is it the other way? So let's check our middle term and see. If I do it this way, I'm foiling here to check. I get 2 sine minus 1 sine. That's +1 sine. So if you're not sure if you factored right, FOIL and check. Now I use the zero product property. Two things multiply to equal 0. One of those must be 0, so 2 sine theta minus 1 equals 0, or sine theta plus 1 equals 0. Set each factor equal to 0. This says, solve each one independently. Sine equals 1/2. Where does that happen? There'll be two answers. Unless we have sine or cosine equal to 1 or -1, we always get two answers. Where does sine equal 1/2? Well, it's positive, so it has to be quadrants 1 or 2. That's a 30-degree reference angle, so that's pi over 6 and 5 pi over 6. Remember, in general, quadratics have two solutions, right? But trig functions have trig equations have double the number of answers you would expect. So even though it's a quadratic, we're not going to get two answers. We might end up getting 4 unique answers. We'll get up to 4 answers. Okay, now let's solve this one. This says sine equals -1. So you can just go to your unit circle. For the ones, the negative ones, the zeros, I prefer to just use the graph. Remember, the ones and the negative ones, instead of getting 2 answers, you only get 1. That's right here at 3 pi over 2. That's where sine equals -1. So let's add that to our list. And then we want to cover all the possible answers. So we put a plus 2k pi at the end. There are the solutions to that one. Okay, now let's solve this trig equation. I've got cosine squared plus sine equals 1. If you've got a mixture of sines and cosines, where one of them squared, the best thing to do is convert over, make everybody look like the one that's not squared. Convert this guy into sines. And the way we do that is, remember, cosine squared is 1 minus sine squared. Okay, now we want to get everything over onto one side. I don't like having this negative sine squared, so I'm going to move everything over to the left side. Notice, by the way, this is pure coincidence, but these ones cancel. That usually won't happen, but it does here. I'm going to move everybody to the other side. And then I want to factor. Normally I would have a squared plus bx, or ax squared plus bx plus c, and I would have to factor into two binomials. But this guy just factors out GCF. I could pull out a sine of x. I'm left with sine x minus 1. I have two things multiplied together to equal 0. That means one of them equals 0. So either sine of x equals 0 or sine x minus 1 equals 0. So where does sine equal 0? Between 0 and 2 pi, at 0 and pi. So x might be 0, might be pi. Where does sine equal 1? I can use the same picture here. At pi over 2. Remember, you're always going to get two answers. For each equation, you're going to get two answers unless it's equal to 1 or negative 1. Then you only get 1. So my third was pi over 2. And then don't forget the plus 2k pi at the end.